What does the Mars look like? Obviously, you will say that it is barren and is dominated by raging dust storms. But would you believe if I told you that Mars wasn't always a barren world? Several chunks of evidence suggest that the red planet was warm, had lakes of liquid water, and was probably habitable for a short period in its history. But if it was like that, a big question arises. How and why did this dramatic transition happen? It is, more often than not, credited to the laws of its magnetic field. A planet's magnetic field decides its course of events. It's an entity that can cause the difference between life and death. So, the laws of the magnetic field was a turning point in the history of Mars. Studying the planet's past habitability has been one of the prime objectives of multiple missions to Mars, including the recently launched Perseverance Rover. The Perseverance Rover has been exploring the Martian land since early 2021, and now it has found strong signals of organic matter on the planet. What does the Perseverance tell about the history of Mars? How did the rover make this significant discovery? Let's find out. Perseverance is a car-sized rover launched as a part of NASA's Mars 2020 mission. The rover and its companion Ingenuity helicopter landed on Mars on February 18, 2021. Consequently, it has been exploring the red planet to bring humanity closer to the unanswered questions. One of the most crucial tasks assigned to the rover was to explore the Jezero crater and look for evidence of former microbial life which could be existing in such environments. The special thing about this crater is that it was the rover's landing site. The Jezero crater is believed to have been flooded with water in the past. Perseverance carried 43 sample tubes, 38 of which were asked to collect different samples from various geological locations on Mars. In its first campaign, the rover collected 8 samples. They included igneous rocks, likely formed deep under the surface due to some volcanic processes on the crater ground. After completing the first campaign, the rover arrived near Jezero crater's ancient river delta on 13th April this year to begin its second binge to collect the exclusive Martian samples. And in doing so, it collected 4 new samples, bringing the total count to 12. But what was so special about the Mars samples? What extraordinary things can it reveal about ancient Martian life? The answer to these questions lies in the history of the site. The river delta marks an ancient fan-shaped feature that possibly formed about 3.5 billion years ago at the convergence of a Martian river and a lake. It hosts some fine-grained segments deposited at its base long ago. So this site is the mission's best expectation for finding the preserved remnants of ancient microbial life, which makes the delta one of the best locations on Mars to look for signs of past microbial life. Perseverance found organic materials in the delta by making use of a drill on the end of its robotic arm and a complex sample collection system. Organics have been previously found on Mars by the Curiosity rover. However, the latest detection has been made in an area where sediment and salts were deposited in a lake. The conditions might have triggered the existence of life in past. The samples collected by the rover are pretty diverse. For example, one collected sample is a sandstone that seems to carry grains and rock fragments created far from Jezero crater. In comparison, the other is a mudstone with intriguing organic compounds. A rock about 1 meter wide, and it likely formed billions of years ago as mud and fine sand settled in an evaporating saltwater lake. When the sample collected from this rock was analyzed with one of the rover's instruments called Sherlock, it was found to contain a class of organic molecules that can be correlated with sulfate minerals. This is very interesting because sulfate minerals found in sedimentary rock layers can reveal information about the watery environments in which they were formed. Further, the correlation suggests that when the lake evaporated, sulfates and organics got deposited, preserved, and concentrated in this area, thereby strengthening the fact that Perseverance is exploring at the right place. Organic molecules can act as an indirect indication of the presence of life. These molecules consist of a wide variety of compounds made primarily of carbon as a fundamental ingredient and are usually accompanied by hydrogen and oxygen atoms. They can also contain other elements such as nitrogen, phosphorus, and sulfur. A few of these compounds can be formed by an inorganic process, but some are the chemical building blocks of life. So their presence is considered a potential molecular fossil, serving as possible evidence of past life. In its first two science campaigns, Perseverance has collected an amazing set of Martian samples to be analyzed. Each sample is stored individually in tubes primarily made up of titanium and weighs less than 57 grams each. The tubes have a white coating on the outside that will protect the samples from getting heated by the sun, which can potentially change their chemical composition. All the collected samples have been secured in the tubes, and now the next task is to bring them home for a detailed study. NASA and the European Space Agency are leading cooperation to plan out ways to get the first Martian samples back to Earth in a secure manner. The plan must be to land a sample return lander near the Jezero crater. The lander will carry a small rocket on which the samples collected by the Perseverance will be loaded. On top of that, two Ingenuity-like helicopters are also expected to provide extra support in retrieving samples from the surface of Mars. After the collection, the sample reserve will be launched off the red planet. Then another spacecraft would be deployed, capturing it in the Mars orbit, eventually bringing it back to Earth. Yes, the whole plan is a bit complex and has to be carried out precisely to safely bring the samples from the red planet back to our home. The organizations hope to successfully execute their plans by early to mid 2030. Until then, let's wait and see what shocks does the rover give us next. That's all about Mars, but what do you think about life on Pluto? Watch this video to know. Thanks for watching, and I'll see you in that one.